Right, so now that we have the results of this equation, we're going to take a look at how to check it with your graphing calculator. So we have 120, 240, and 0. I'm going to move on to a new page to just kind of write down what we would do checking-wise. First thing you'll want to do is go back to your original equation and get your equation equal to 0. Kind of like you would do if you were doing a quadratic equation also and you were trying to solve for those solutions. Some of these are quadratic, some of them aren't, but this technique works for all of them. So here's our original equation. The only thing we would have to do is get it equal to, to get it equal to 0 is to subtract the 1 from both sides. Now, if we're typing this in the calculator, in y1, we're going to put in the following. Now, tangent squared is a short notation for the tangent function squared, and in fact, you're going to even get an extra parentheses around each of your x's. Secant is 1 over cosine. So in order to successfully type this in, you do need to know your reciprocal function information for that. So this is going to be the left side of our equation. I'm also going to plug in the right side. You don't have to do this, put in the 0, but it will help you. There's an option for doing an intersect method as opposed to second trace 0 when we go to do it. Now with our window, you do want to be in degree mode. I might do an x-min of just -10 so I can see everything. You could do 0 to 360, and I'm going to do an x-max of 370. If you're solving something from 0 to 360, you really could just do 0 to 360, whatever your min and maxes of your situation. So if it asks for 0 to 360, then you could put in 0 to 360. I just like a little bit on either side, just in case one of the answers is on actually 0 or 360. Oops. And I already moved over to the calculator by accident. Sorry about that. So my other thing with x scale, you don't really have to change that. I'm going to change it to 90, but you don't have to. And then y min and y max, I'm going to leave at -10 to 10. If you can't see what you need to see, that'll be up to you how to fix that. And then we're going to do second trace intersect. You could do second trace 0 as a different option. But I like the intersect for this because it makes it nice and quick and easy. If you wanted to do 0, then you would not need to put in the y equals 0 part of the calculator. Okay, and then once we get to here, I just want to move this down a little bit. I'm going to sketch what this graph looks like after the fact. So we're going to go to the calculator, make sure your mode is in degree mode. Should already be in that mode. And then we are going to plug in the tangent, x, close the parentheses, squared, plus 1 over cosine. Now you could use a fraction tool for that. You don't need to, so I just chose not to do it. And then -1, and then we'll put 0 in the second spot. Again, for my window, since I want to see all of the solutions, I'm putting in -10. Whoops, that is way too much. -10. 370. If you want to do 0 to 360, that is fine. An x scale of 90. And then we'll leave everything else the same. So if you want to just check out the graph picture so that you can get a nice sketch on there for yourself, you can do that, and you can kind of see where it is intersecting. That was important for this question for me to have it going through at 0, because that looks like it might be one of my intersection points. So when I go to this, I'm going to go do my sketch. All I'm really looking for on the sketch is that you have a picture that kind of looks like what your calculator looks like. It shows your window. Now remember, it's 0 to 360. So we're not including 360 since we're using a parentheses, which is why 0 ends up being our answer as opposed to the 360. And we have these intersection points. We know we have 0, although I'm going to do that one. And then we have the other two, which should be 120 and 240. So great way to check it or to solve it if I ask you to solve by graphing. So we'll go to the calculator. I'm going to do second trace intersect. If I do this method, I like to scroll up to the y equals line because it's much easier to then scroll across to the points that I want to get. Now I already know the 0 one, but if I wanted to get 0, I would get close to it, hit enter 3 times, and the third time gives me the 120, so that's one of the values, and then I can do second trace intersect again. Oh, I must have not hit the right buttons. Again, scroll up so you're on that line. If you have the color calculator, you can really see which graph you're on if you have them set to be different colors, which is nice. If you don't have it, it's not a big deal, but it is a nice feature. Get close to the other one, hit enter 3 times, and it gives me my second guess. So all your labeling on here would be 120, 240. I probably should put these as comma zeros because they are zeros of the graph. And then technically this is 360, 0, but again, this one is not included because we're only having you solve from 0 to 360, not including the 360. So if you're picking which one between 0 and 360, it's always going to be 0 that you're choosing because it has the closed bracket. So this is a nice way to check. It will be something that you will do solving-wise, also on the test, just solving by graphing. So making sure to know how to type it in to get a good window for that is important. And also making sure you're in degree mode whenever you're doing these, otherwise the graphs won't come out nicely.